Hello, College Algebra, and welcome to Chapter 5. Okay, this is about equations and linear equations and inequalities in two or more variables. The first section is just linear equations and solving. So these are things that are easier to graph, and we'll continue and go. So make sure you get your chapter notes out. You might need a calculator and your pencil. All right, here we go. So now when we're doing this, we're doing systems of equations in two variables. So we have to decide whether an ordered pair is actually a solution, so does it work in both lines. To solve the system by substitution, so we use substitution. We will solve by addition, which you probably know as elimination. Okay, we're going to identify systems that don't have an ordered pair for a solution, and we're going to talk about systems, solving story problems with systems. Okay, here we go. I want to know is a system of two lines, just a linear system. So I have two lines, and do they cross? Consistent, that means the lines intersect in a point. Inconsistent, the lines do not intersect. There's also another one called consistent dependent, and that's where they intersect in more than one point. But we're just going to do consistent where they have one or more points in common. Okay, now I want to know if an ordered pair is a solution of a linear system. To do this, we're going to give you an ordered pair or a point, and we're going to give you two equations. What you have to do is plug the ordered pair in, so the 1 for the x and the 2 for the y, and see if it equals the -4. And you have to do the same for both equations. So we plug it in here. 2 minus 6, does that equal -4? The answer is check. Now we plug it in here. So we have 2 plus 2, does that equal 4? And the answer is check. So yes, this is a solution. These two lines meet at that point. So next, your turn. So a 7, 6 is a solution. So do these two lines meet at 7, 6? So the first thing we do is we do 2. Whoops. Let's go down here. Try that again. Okay, so let's do this again. So now you're putting your 7 in for your x and your 6 in, maybe, there we go, and your 6 in for your y. So we have 14 minus 18. Does that equal -4? The answer is check. Next one, we do this again down here. So we have 14 plus 6. Does that equal 4? Whoops, sorry, 4. That was terrible. The answer is absolutely not. So this does not, come on, go away. So does this equal 4? The answer is no, this is not true. So the answer is no, this is not a solution to our thing. It's not a solution. All right, these two lines do not intersect at 7, 6 is what that is saying. All right, substitution. This is where we solve for one variable. Then we take that equation and we plug it into the second equation right here. We solve for the second variable. We take the solution of that variable and plug it into the first equation or the second, doesn't really matter. Solve for the remaining variable, and then we check our solution. So it might have been a while since you've done this, so let's check. Now, when I give you your homework or your quiz and I say solve by substitution or solve by elimination, if you use the other method, it will not count. So make sure you read your directions carefully. This one said substitution. So I'm going to look and see which one is easiest to solve for. Well, when I solve for x here, I'll have to divide by 3. Y, I'd have to divide by 2 on this one. This one, I'd have to divide by 2 on x, but this y has nothing attached with it. So I won't have to divide when I solve. That usually eliminates working with fractions and makes it a little easier. It is not wrong to solve for any of these. So I'm going to choose this equation, and I'm going to solve for y. You can do whatever you want. When I solve for y, I subtract the 2x. So I have y equals -2x plus 1. So next I have to choose this equation. So second, I choose the one I haven't used. I look for the y, and I'm going to replace this y with what it's worth. So in its spot, I'm going to plug in -2x plus 1, or I'm going to use substitution. So it's 3x plus 2. Now instead of times y, it's times what y equals, which is the -2x plus 1 equals 4. And now you're doing your order of operations. So first we're going to distribute that 2. So we're going to get -4x plus 2 equals 4. We're going to combine like terms here. So minus x plus 2 equals 4. Subtract your 2. So negative x equals 2. Divide by negative 1. So x equals negative 2. So we've got our first section down, but now I have to find the y. All you have to do now is take the negative 2 and plug it into either one of those equations. It really doesn't matter. I picked the first one just because, but you could have easily have picked the second. Might have been easier because of smaller numbers. It's irrelevant. So now I'm going to plug negative 2 in for my x because that's the value I found. Now we're going to solve. So negative 6 plus 2y equals 4. We're going to add our 6. So 2y equals 10, which means y equals 5. So y equals 5. So my solution to this is, you have to write it as an ordered pair. It is a point. So it's negative 2, comma 5. All right, to check, you actually have to plug them in. Well, if I look here, the negative 2, so we do 3 times negative 2 plus, 2 times 5. Does that equal 4? And the answer is yes. Negative 6 plus 10 is 4. Check. And then you should also check the other equation. So that one was 2x plus y equals 1. So it's 2 times x plus y. Does this equal 1? And the answer is check. So you've done your work correctly. But this is the answer. So when I ask for the solution, I'm asking for that ordered pair. Okay, pause and try yours. So if I was you, I would have solved for x, even though any of them are acceptable. So now we have x equals, we're going to add the 2y to the other side. So now since I solved this one, I have to substitute into the second one. So I have to use this equation. So I'm going to take the x out, and I'm going to plug in what x is worth, which is the 2y minus 3. So I'm substituting that value in for x, minus the 4y equals 9. I have to bring down the rest of the problem. So 10y minus 15 equal, minus 4y. Let's erase some of that there. Maybe. It's not going. There we go. All right, let's try that again. Minus 4y equals 9. Combine your like terms. So we have 6y minus 15 equals 9. Add your 15. 6y equals 24. And divide by 6. You have y equals 4. All right, you've got the first part, so now you got to plug it into one of the others. Let's choose this one this time, just because it looks fairly easy. So x minus 2 times 4. I don't know what's wrong with me today. Here we go. There we are. Okay, let's do that again. 2 times, maybe. Equals negative 3. So we got x minus 8 equals negative 3. Add your 8 over. X equals 5. And our answer is 5, 4. All right, I hope you did well. You should be plugging them in to check, and you will find that both solutions. Okay, elimination is where you have to eliminate a variable by getting opposite coefficients. So first thing we do is we put it in ax plus by equals c form. We get opposite coefficients of one of the variables, either the x or the y. Then we add the two equations together, and then we solve for the remaining variable and substitute it back in. So this equation right here is in the right form. It's ax, or 3x plus 2y equals 4. So the x's plus the y's equals the number. This one is not. The 2x has to go first. We need to move it to the other side. So we're going to add it. So now we have 2x plus y equals 1. It is now also in the same form. Now we're going to look at this and eliminate a variable. We can do x or y. Well, when I'm looking at this, I'm thinking, hey, if I multiply the x, I need a 3 here and a negative 2 here to get opposite. The y, I only have to multiply by a negative 2 because the other one is okay. So the 3x plus 2y equals 4 does not need anything done to it. When I multiply -2, I have to multiply everybody on both sides of the equal sign. So this is -4x minus 2y equals -2. After you have that done, you add the equations together. When you do this, one of the variables should drop out. So 3 minus 4, well, that's a -x. The y's are going to cancel, equals 2. Let's continue down here. I need some more room. All right, so we got x equals, so that means divide by a -1. So x equals -2. We have to pick one of these to substitute it back into. Let's do the top one this time. So now I'm going to take and plug in -2 in for my x. So 2 times -2 plus y equals 1. -4 plus y equals 1. So y equals 5. So our solution is -2, 5. If you notice, it's the exact same problem we did on the other page with substitution. And we get the same answer. So we can check, but we've already done so. So we know they do work. Okay, do yours using elimination. Okay, you could have chosen the x's or the y's. Both of them are equally the same. The x you'd have to multiply by -5, and the y you'd have to multiply by -2. It doesn't matter which one. I'm only going to choose one, and I think I'm going to get rid of the x's just because. So I need to multiply this guy by -5. So I know my first equation is okay. So that's 5x minus 4y equals 9. Distribute your -5 through to everyone. So we have a -5x. Distribute it through here. Be careful with this sign right there. So negative times a negative, remember, is a positive 10y equals, and then again a negative times a negative is a 15. The x's are going to cancel. We have 6y equals 24. And divide, and y, whoops, sorry, that's by 6. Y equals 4. Same answer we got last time, so life is good. Now we need to substitute this back in. Doesn't matter which one. I'm going to choose the bottom one just because it has less numbers in it. So now we're going to plug the 4 in for the y. So we'll have x minus 2 times 4 equals -3. So x minus 8 equals -3, and x equals 5. So our solution is 5, 4. That's where these two lines intersect. And we actually already checked it on the other page because it's the same problem. All right, this is what your lines can look like. So when they intersect at one point, that's called an exact solution. There's one answer. All right, those are the consistent lines we've been talking about. And that's actually all of them you've had so far. You've got one solution set, so they're intersecting at one point. There can be no solution, or the lines are parallel, so they don't ever intersect. That's called inconsistent. So there's no solution. So this solution is some kind of a point. I should write that down. All right, you will get something weird when you solve these lines. It's going to be something like 5 equals 4. And you know that that's not possible. So when they cannot be equal, then they're inconsistent. They're parallel lines. The other type, this is actually a line on top of a line. There's two lines here. They're the same line. They're also consistent. And you have infinite solution sets, is how we write that. Now, when you get something like this, it's going to be something very nice, like 7 equals 7. Or it could be x equals x. Whatever it is, it's the same thing on both sides of the equation. That's consistent. That's the exact same line. All right, let's see what we have here. We can solve by elimination or substitution. Well, 5 and 10, that looks like a pretty easy solve. So I'm going to multiply this equation by 2. So now this one needs nothing. So the -10x plus 4y equals 7 is fine. Distribute my 2. I've got a positive 10x. I have a -4y equals an 8. So you distribute it to everybody. Now when we add, though, the x's and the y's go away. So we've got 0 equals 15. This is absolutely not possible. It does not make sense. So it's one of your parallel lines. It is inconsistent. Whoops. And there is no solution. All right, try yours. This one here is set up for substitution. If you notice, it's already solved for the x, so we might as well do it that way. 5 times. You can do it the other way and solve and put the y on the other side and solve. That is also fine. All right, let's distribute this 5 through. So we have 20y minus 40 minus 20y equals negative 40. Well, the y's cancel. We have negative 40 equals negative 40. This is always true, right? There's no time this is not true. So these are consistent lines, actually consistent dependent lines, and they have infinite solution sets because all the points are the same. They intersect at every point on both lines. All right, we're going to talk a little about a cost function and a revenue function. So a cost function is what it costs you to get something or make something. The revenue is how much you are selling it for. So like if you were running a concession stand, what it cost you to buy all the candy would be your cost function, like how much you spent. Your revenue is what's in the drawer at the end of the night. The profit is when you subtract those two. But right now we just want to worry about cost and revenue. So a company that manufactures running shoes has a fixed cost. So we have a fixed cost equals $300,000. Okay, it costs $30 to produce a pair of shoes. So $30 per pair of shoes. They are sold at and they sell for $80 per pair. All right, so when we look at this, I have to create a cost function. A cost function is always written with a capital C, X. That means C of X, the cost of producing X amount of shoes, is equal to. Now, if it's $300 fixed and $30 per shoe, the $300 is what it is, like your startup cost. How much does a building cost and the machines and all those? That's a fixed cost. Then it's $30 per shoe. So I'm going to let 30 be our shoes be my X since I put an X here. So it's 30 times the number of pair of shoes I make. So that's how much it's going to cost to make the shoes, plus my 300,000, which is my startup cost. Okay, your revenue function is always written R of X, and this is how much you take in. So it's $80 times the number of pair of shoes you sell, and that's all there is to revenue. The break even is where they meet. So you set these two equations equal to each other and you find your break even point. So we'll go 80x equals 30x plus 300,000. Subtract your 30x. So 50x, I am so out of room here. Like so. Equals your 300,000. Divide by 50. And you're going to get x equals 6,000. So when you make 6,000 pair of shoes, you break even. So to make money, you have to make 6,001 pair of shoes, and so on. Anything under 6,000, you lose. Anything over 6,000, you make money. That's a break even point. Okay, try yours. Make sure you write down your know and your don't know. Okay, you should have written down fixed cost was 40,000, $3 to make my donuts. I know there's two ways to spell donuts. I've never figured that out. And they sell for $8 a dozen. All right, I want to know my break even. All right, so first I have to create my cost function. So my cost function is $30 per dozen donuts plus my 40,000 startup fee. So how much did my building cost me? My revenue, so how much do I have in the cash register, is $8 per dozen. My break even is you set those equal to each other. Subtract your 3x and divide by 5, and you should get 8,000. So you got to make 8,000 dozen donuts. That sounds really funny. But you got to sell 8,000 dozen donuts in order to break even. So 8,001 is when you finally make money. All right, last but not least, our mixture problems. And mixture problems are not hard as long as you break them up. If you do not break them up into small portions, they are difficult. All right, so in a mixture problem, you have everything that goes in the mixture here. And the very last line is the mix itself. Here you put down there's got to be a number of them or a quantity. All right. And here is value per unit. And this can be anything from dollars to percent to whatever they are doing. And the total is when you multiply these two together. So you multiply these to equal this. And then you take this one in your total, the first line, plus the second line and the third line and so on, and that equals your bottom. All right, let's get moving here. See if we make this make sense. A chemist working on a flu vaccine, should be COVID right now, huh? Needs to mix a 10% sodium iodine. So my solution one, I don't really care it's sodium iodine. I just know it's my first solution. I have 10% of it. So I'm going to put 10% here. I'm going to put percentage with 60%. So my solution 2 has 60% to obtain 50 milliliters. So I'm dealing in milliliters, and I know I want a total of 50. And that has to be 30%. Okay. How many milliliters of the 10 and the 60? So how many of both of these? So these are my variables. X and Y is what I do not know. So now I got to create my equations. So I'm going to multiply, and I get 0.10x here. Multiply here, that's 0.6 y. Multiply here, and I got 15. So I know 0.10x plus 0.60y equals 15. That's my equation. A lot of times, this here will be all I will need when I create this, but this time, the variables are up in here. So let's see what we got. I know that x plus y has to equal 50 because that's how many total I want. So now that I have my two equations, we have to do elimination, substitution, and it looks like elimination will be the easiest. So let's multiply this guy by a negative 0.10. Distribute that through. So I got a negative 0.10x minus 0.10y equals 50 times negative. It should be a negative 5. Okay, let's add these up. And we're going to get 0.5y equals 10. Divide by 0.5, and we get 20. So y equals 20 milliliters. Well, if y is 20 milliliters, and I know x plus y is 50, so that means x plus 20 has to equal 50, that where x has to equal 30 milliliters. So I need 20 milliliters of the 60% solution and 30 milliliters of the 10% solution to create my 30% solution and get 50 milliliters. Okay, let's look at this one. Another way of doing it. This one here is where they do substitution in the table itself. The chess club is selling popcorn mixed with M&Ms. So my two things are popcorn and M&Ms to raise money for their competition. Popcorn cost, so one of these is going to be cost. So this is dollars, 10 cents. So popcorn is 10. So far I filled this in. And M&Ms cost $1.25. So now I can fill this in. All right, so we got this and this done. They want to create a mixture that costs 20 and 20 cents. So we filled in this entire column. How many cups of M&Ms? So M&Ms is my variable. That's what it said. Must be added to 100 cups. So I got 100 cups of popcorn to make my mixture. Well, now they didn't tell me what my total mixture was. They told me what I used to get there. So to get this here, I have to add these two together. And I get 100 plus M. Now we're going to multiply. Get 100 times 0.1. So we got 10 here. Multiply 1.25. Here we take the 20 times 100 plus M. So remember now I add these up and this equals this total. So let's do that. We're going to get 10, whoops, plus 1.25 m, and I'm just going to leave this for right now. So 20 cents times 100 plus m. Now to solve, this here's where your substitution actually came from, because it came from the 100 plus m, which is really nice. Okay, so now we're going to solve, and we're going to get 10 plus 1.25 m equals 20 plus 0.20 m. Okay, let's subtract the 0.20 m. Let's subtract the 10, move that to this side. So now we've got 1.05 m equals 10. Divide by 1.05. And we have M&Ms equals 9.5 cups. So I need 9.5 cups of M&Ms to mix with my 100 cups of popcorn so I can sell them at value of them at 20 cents each. What I'm going to sell them at, who knows? Probably 50 to $1. I need to make money, right? How many ounces? Now it's your turn. So pause and try this, and really pause and try this. Okay, how many ounces of a 50%? So I know I have ounces and I have percent. 50% alcohol solution. So this is solution 1 and it is 50%, so 0.5. Must be mixed. I don't know how many ounces, put an X there. With 80 ounces, so I got 80 ounces of this one. 20% solution, 20% here. This is solution 2. To make a 40%, I want to make 40%, so this has to be 40 here. And this is my mixture. So that means I have X plus 80 ounces at 40%. So I have 0.5 X, multiply these together, and I get 16. Don't need a decimal there, I'm pretty sure. Oh, and never mind, it didn't print. Okay, 16. And now we have to take the 0.40 times the X plus 80. Substitution is done in the table, so now I have to create my equation is all. So 0.50x plus 16 has to equal 0.40 times x plus 80. Distribute. So we have 0.5x plus 16 equals 0.40x plus, let's see, 40 times that would be 32. All right, so next we have to subtract. So let's subtract the 16. Let's subtract the 0.4. So now we have 0.1x equals 16. So x is equal to 160 ounces. That's how much I need of solution 1. All right, good luck with your homework. I hope you do well. Have a great day.